When you walk into a massive multi-story hospital, your brain doesn't really focus on the engineering.
Right, you're definitely not looking at the foundation.
Exactly. You just
Yep.
trust that the building isn't going to, suddenly collapse around you. You don't spend a single second thinking about the steel I-beams hidden inside the drywall.
No, of course not. You're just looking for room
Yeah,
numbers.
the room numbers, the painted arrows on the floor, the exit signs, just to get where you're going.
And that physical structure itself is entirely invisible to you. Your eyes are drawn to those surface level navigation tools, but I mean, those steel beams are doing absolutely all of the heavy lifting.
Right.
Without them, the painted arrows and room numbers are literally just debris.
Well, today we are tearing down a different kind of invisible architecture. We're doing a deep dive into the hidden engineering of how you read.
Specifically something called text structure, which is so crucial.
It really is. Whether you are, staring down the barrel of the TEAS or HESI nursing entrance exams, or you're just someone who needs to absorb complex information without feeling totally overwhelmed, this deep dive is going to hand you a flashlight.
It's a game changer, honestly.
Our mission today is to figure out why some reading passages instantly stick in your brain, like they were super glued there, while others just kind of slip away into the void. And spoiler alert, the secret isn't actually what you read, it's how it's built.
Yeah, we are going to look way past the surface of the words on the page. We really have to examine that hidden architecture.
Because it's not just an academic thing, right?
Not at all. Recognizing how an author builds a passage isn't just some abstract exercise. Once you understand how to spot these underlying patterns, it transforms from a basic reading strategy into a highly critical and sometimes literal life or death skill in a clinical setting.
I definitely want to get straight to how we can use this to ace an exam or read a medical chart. But first, I'm getting a little tangled up in the terminology. We need to isolate exactly what text structure is.
That's a good place to start. Yeah.
Because I feel like a lot of people conflate the content of a passage with its features and its structure. Are we just talking about looking for bold fonts and bullet points?
So confusing those three elements is actually the #1 reason people struggle with reading comprehension under intense time pressure.
Well.
Let's separate them out.
Okay, wait on me.
The content is simply your subject matter, just what the passage is literally about. The facts regarding a disease, a historical event, whatever.
Right.
The text features are the visual signposts. Think of headings, bold print, italicized words, bullet points. Those are printed on the page specifically to catch your eye.
Okay, so the content is the stuff and the features of the visual pop.
Yes, exactly. But text structure is the underlying logical relationship the author deliberately chose to connect their ideas together.
The relationship between the ideas.
Right. Is one specific event causing another event? Are two separate conditions being compared side by side? It is the skeleton of the passage, the logic holding the facts in place.
Wait, let me try to visualize this with that house analogy.
Go for it.
If a passage is a house, the content is the furniture inside. The text features would be the bright neon signs outside pointing to the front door, or maybe like a brightly painted door.
Yeah, the things you notice immediately.
But the text structure, that's the load-bearing walls and the floor plan. Like, you can have a house with absolutely no signs outside, but you cannot have a house without walls.
That is a perfect way to look at it. A passage can easily have 0 text features. You might encounter this giant, intimidating block of plain text with no bold words, no helpful headings.
Just a wall of text.
Exactly. Yet it can still have a rigorous, perfectly engineered text structure. And in the world of nonfiction, which educators call expository reading, researchers have identified 5 core structures that form these load-bearing walls.
And for anyone listening who is prepping for a nursing exam, these happen to be the exact 5 structures you will be tested on, right?
Absolutely.
So let's lay out this big 5. First, we have cause and effect, where one condition produces a specific result. Then, compare and contrast, looking at similarities and differences.
All right, those are 2 of the biggest ones.
Then we have sequence, which covers chronological events or a step-by-step process. Fourth is problem and solution. And finally, description, which is sometimes called collection.
Yeah, collection is a good name for it. It's basically a list of characteristics or examples about a topic without any strong logical connector forcing them into a specific order.
So it's just, here's some facts about a thing.
Pretty much. And, the way our understanding of these five structures has evolved is genuinely fascinating.
How so?
Well, early on, researchers thought of text structure exactly like your house metaphor. They viewed it as a fixed, static thing that the author built once and the reader just passively walked through.
Like a museum exhibit.
Right. But cognitive research entirely flipped that notion. Today, we understand text structure as a dynamic relationship between the text and you, the reader. It's a mental schema.
A mental schema. So the structure doesn't really exist just on the page.
Exactly. A beautifully written cause and effect paragraph is completely inert ink on a page until your brain actively slots those incoming sentences into a cause and effect mental frame.
Oh, wow.
Your brain has to recognize the pattern and say, I need to open my cause and effect file folder to actually understand this.
Which makes me wonder about the history of all this. Did we always understand reading this way? Where did this framework of the Big Five even come from?
The modern understanding traces back to the 1970s, specifically to a cognitive psychologist named Bonnie J.F. Meyer. In 1975, she published this landmark piece of research,
What was it called?
The Organization of Prose and Its Effects on Memory. But she was actually building on the work of a British psychologist from the 1930s named Frederick Bartlett.
Oh, Bartlett. He developed schema theory, right?
Yes, exactly. Schema theory.
That's the idea that our brains use pre-existing templates to understand the world.
Right. He proved that when people hear a story, they do not memorize it word for word like a tape recorder. Human memory doesn't work like a hard drive storing exact files.
So what do we do instead?
People reconstruct the story later using pre-existing mental templates in their minds. And at the time Bonnie Meyer was working in the 70s, other researchers were busy mapping out story grammar for fiction.
Story grammar. Like knowing that every fiction story has a setting, an inciting incident, a climax.
Yeah, we all inherently know that rhythm. So Maya looked at fiction's grammar and asked, well, does nonfiction have a grammar too?
And that's where the Big Five came from.
Exactly. She formalized expository text into those five organizational patterns, and her crucial contribution was proving that your ability to remember a passage depends heavily on your brain's ability to detect that specific nonfiction pattern.
So if you can't see the pattern, you can't remember the facts.
Basically, yeah. And this caused a massive paradigm shift in education. Before this, reading was often treated as a totally passive activity.
So before the 1970s, did researchers really think reading comprehension was just about being a human vacuum cleaner? Like
Yeah.
you just drag your eyes across the page and suck up a bag of random disconnected facts.
That is pretty much exactly how they viewed it.
That sounds incredibly exhausting and
Yeah.
totally inefficient.
It was. Older models treated a passage as an undifferentiated bag of facts. Schools tested comprehension simply by asking readers to recall isolated, random details.
Just trivia, basically.
Right. But the cognitive revolution of the 70s and 80s reframed reading entirely. It stopped being about passive absorption. It became an active, structure-building process.
That's so much more empowering.
It really is. And this research eventually moved from psychology labs into actual classrooms in the 1980s. Researchers like Carol Sue Englert and Taffy Raphael started developing writing frameworks explicitly built around teaching students to be hyper-aware of this underlying structure.
The Tower and Power framework.
Yeah.
It completely tracks. I mean, if reading requires this active mental slotting, this matching of text to a mental schema, I'd want to see the proof. Does finding the right mental slot actually improve human memory in a measurable way?
Oh, absolutely.
Because if we're going to use this to pass exams, we really need to know it works.
The proof comes down to a fundamental first principle of cognitive science. Human memory is designed to store relationships, not isolated facts.
Okay, give me an example.
Imagine I hand you a list of 10 completely unconnected facts about the human kidney. You are going to struggle to memorize them. Your brain has nothing to tether them to.
Right, they're just floating there.
But if I give you those exact same 10 facts, organized logically as the sequence of steps in blood filtration, your brain suddenly has a scaffold. You can hang those details on the scaffold.
They proved this in a lab setting, didn't they? There was a famous study in 1984 by Meyer and Roy Friedel.
Yes, the 1984 study is a classic. They took a group of adults and had them read highly technical information about the presence of nitrates in food processing.
Sounds thrilling.
Oh, incredibly dry material. But here is the brilliant trick they pulled. They gave all the readers the exact same underlying facts, but they wrote the passages using different text structures.
So the content is identical, but the load-bearing walls are different.
Exactly. One group got a compare and contrast version, another got a problem and solution version. A third group got a loosely organized collection version, which was essentially just a descriptive list of facts about nitrates.
And what happened when they tested them?
When they tested the readers afterward, the ones who received the comparison and problem solution versions remembered substantially more information.
Oh.
The facts were identical down to the letter, but the underlying architecture, the way the information was arranged, materially changed what the human brain was capable of retaining.
That just blows my mind. The content wasn't the variable. The delivery system was the variable.
Yeah, exactly.
And the research gets even more specific regarding who benefits from this, right? Like in 1989, Meyer and some colleagues conducted another study, but this time focusing exclusively on older adults.
Yes. And this is fascinating because usually the assumption in cognitive psychology is that as people age, their raw ability to recall prose naturally declines compared to younger adults.
Right. It's just viewed as this inevitable hardware degradation.
But in this study, they trained these older adults to explicitly look for text structures before they started reading, specifically focusing on problem solution and comparison patterns.
So they gave them a clear strategy.
They did. And when they did that, the older adults basically closed the recall gap. They nearly matched the performance of untrained younger readers.
Wait, really? Just from learning the patterns?
Yeah. It's a staggering finding. It completely changes how we view cognitive aging in relation to reading comprehension.
Wait a minute. If they just train them to look for patterns and their memory performance bounced back, that means the aging memory penalty everyone talks about isn't totally about raw hardware degrading.
Right.
It's a software glitch. They were defaulting to a detail-by-detail vacuum cleaner reading strategy, and the structure training was basically a software update for their brains.
The software update analogy perfectly captures what's happening cognitively. You are installing a more efficient processing program.
I love that.
This is precisely why text structure recognition is taught as an active reading strategy today. It's not just a neat organizational trick for writers. It is a defensive tool for readers to actively deploy. The pattern drives the retention.
Okay, so let's bring this into the clinical battlefield. Knowing that this is a literal cognitive superpower, how do high-stakes tests actually evaluate your ability to use it under pressure?
Let's look at how this manifests on something like the TEAS exam.
Because if you're sitting in a testing center staring at a screen, you only have minutes to read incredibly dense medical passages.
Right. Imagine a passage on the screen that reads, insulin allows glucose to move from the bloodstream into cells. When the pancreas fails to produce enough insulin, glucose builds up in the blood, a condition called hyperglycemia. Over time, elevated blood glucose damages blood vessels, which can lead to complications such as kidney disease and vision loss.
Okay, that is a dense paragraph. But looking at the load-bearing walls, it's a textbook cause and effect chain.
Exactly.
Insufficient insulin causes the hyperglycemia, which in turn causes the vessel damage, which then causes the organ complications. It's dominoes falling.
Now imagine the multiple choice question asks, what is the effect of the pancreas failing to produce enough insulin?
Okay, let me put myself in the shoes of a stressed-out student. If I'm using the old human vacuum cleaner method, I'm probably just skimming the text, frantically trying to pattern match the keyword pancreas.
And you'll find it, but...
I'll find the word, but then I'll get lost in this soup of glucose and hyperglycemia and blood vessels. I might just pick an answer that says kidney disease because it was near the bottom.
And that's exactly how they get you. The keyword matching fails because it ignores the relationships between the words. You just get lost in the details.
But with the software update,
Right. If your brain has been updated with that structure software, you instantly see the causal chain. You don't just hunt for pancreas. You find the trigger, you trace the dominoes falling one by one, and you arrive at hyperglycemia.
you find the right answer in seconds without panicking.
Exactly. And the same principle applies to compare and contrast passages.
There's a great example from our sources of a clinical passage describing type 1 versus type 2 diabetes.
Oh, yeah, that's a classic one.
It outlines how type 1 is an autoimmune condition requiring insulin from the onset, while type 2 is associated with insulin resistance and often managed initially through diet and lifestyle.
And when you read that, the structure isn't just revealed by surface transition words like unlike or whereas.
Right, because the true architecture there is revealed by the parallel organization.
Exactly. The author is addressing the exact same set of attributes for both conditions. They cover the cause of type 1, then the cause of type 2, the onset of type 1, then the onset of type 2, the treatment for both.
That parallel symmetry is the structure.
You don't need a single transition word to see two columns of information being built side by side.
This all makes perfect sense for cause and effect or comparing two things. But what if two structures look almost identical?
What do you mean?
Well, if I'm reading a sequence passage and a description or collection passage, they both just look like long lists of information, right? A sequence is a list of steps. A description is a list of traits. How do I tell them apart without freezing up on the exam?
That is one of the most common and honestly most lethal exam traps. The crucial difference comes down to one rule-order dependency.
Order dependency.
Sequence requires that the order of the items strictly matters. If you are reading a list of steps in a clinical process or chronological events in a patient's medical history, you absolutely cannot rearrange them.
Because if you reorder the steps of, say, inserting an IV line, the entire procedure breaks down.
Right, it loses its meaning entirely.
So sequence equals a rigid, unbreakable timeline.
Conversely, in a description or collection passage, the order is totally arbitrary. If an author writes a paragraph listing 5 distinct symptoms of a respiratory infection, it functionally doesn't matter if they list a cough first or a fever first or fatigue first.
Oh, I see. You could scramble the sentences, and the overall meaning of the passage stays exactly the same.
Exactly.
Order matters versus order doesn't matter. That is a fantastic distinction to keep in your back pocket. But, if this framework is so powerful and so easily defined, why do people still fail these questions? The test makers must know we're on to them. They have to be setting traps.
Oh, they absolutely set traps. And in the reading comprehension world, there is actually a legitimate ongoing debate about this.
A debate.
The core question is, does explicitly teaching students to label these structures actually improve genuine comprehension, or does it degrade into a mechanical, robotic, test-taking exercise?
Like you aren't even reading the passage anymore. You're just doing a word search for structural clues.
Exactly. Large-scale meta-analyses, including comprehensive reviews by the National Reading Panel, have found that explicit structure instruction works wonders, especially for struggling readers or younger students encountering dense nonfiction text for the first time.
It gives them that necessary scaffold we talked about.
Right. However, highly skilled adult readers often detect these structures implicitly. They don't need to consciously say, problem-solution frame to utilize it. The danger arises when test prep courses try to shortcut the system.
You're talking about the famous failure of over-relying on signal words.
Yeah, the signal words trap.
I remember teachers used to give us lists of words to memorize, like just look for the word because, and you instantly know it's a cause and effect passage, or if you see the word first, it has to be a sequence.
And test makers know that students are taught those shortcuts, so they deliberately exploit ambiguous signal words to punish test takers who aren't reading for deep meaning. The word since is arguably the most classic trap on these exams.
Okay, let me see if I can spot the trap. If I read the sentence, since the medication was administered, the patient's fever dropped. Okay, that is a clear causal relationship. The medicine caused the fever to drop. The word since means because of.
Correct.
But what if the sentence is, since 2010, hospital readmission rates have been closely tracked?
Right, that second sentence is purely chronological. It's a point in a sequence of time. There is zero cause and effect happening there. The year 2010 didn't magically cause the tracking to occur.
Yeah, that makes sense.
If a student has been rigidly trained to spot the word since and blindly click cause and effect on the multiple choice screen, they fare. The test makers deploy those trap words specifically to weed out people who are just keyword hunting instead of processing the logical relationship.
So treating signal words like a cheat code is a massive trap. I guess signal words are basically like a driver's turn signal in traffic.
Well, I like that.
Like it strongly hints at what the driver might do next, but you still have to watch the actual car to see if they make the turn. You can't just trust the blinking light.
That's a great way to put it. Watch the vehicle, not just the signal.
But there is another layer of complexity that feels kind of unfair. What if passages are nested together like rough-in nesting dolls?
The hybrid monsters?
Yeah. How is a student supposed to pick just one answer on a multiple-choice test if there are multiple structures? Like, say I'm reading a massive passage about antibiotic resistance. The whole thing might be a giant problem and solution frame.
Right.
But buried inside paragraph 2, there's a mini cause and effect section explaining exactly how overprescribing leads to resistant bacteria.
These are known as hybrid passages, and it's exactly where a lot of test takers freeze up. They spot both structures, assume it's a trick question, and they just panic.
So what's the strategy?
The golden rule for high-stakes exams like the TEAS or HESI is the test is looking for the overall dominant organizing pattern of the passage as a whole. They are almost never asking about the microstructures buried inside a single supporting paragraph.
Step back and look at the forest, not just the trees.
You have to ask yourself, what was the author's primary overarching goal in writing the entire piece? Was the whole piece designed to present a crisis and solve it? Then it's problem and solution, even if they used a brief causal chain to explain the crisis itself.
Step back, find the dominant frame. I love that, but let's take a step back ourselves. Beyond passing an exam, why does this cognitive tool actually matter?
It matters a lot.
Because getting a good score is great, but nobody wants a nurse who only knows how to hack a multiple-choice test. We need this to translate to the real world.
The real-world stakes in a clinical environment are massive. Imagine you are a working nurse and you are reading a dense medication insert or a brand new clinical protocol. You're tired, you're likely under time pressure.
A very realistic scenario.
You need to rapidly and accurately detect the structure of what you are reading. Are you reading a sequence of steps that you must follow in exact, rigid order for a complex dosing schedule? Or are you reading a conditional cause and effect warning about a severe drug interaction?
Misreading a conditional cause and effect warning, something like, if taken with this specific counter drug, the patient's blood pressure will plummet, and mistaking it for a simple, unordered list of associated facts that has terrifying safety implications.
It is literal life or death. The underlying structure tells you how to act on the information.
And honestly, even outside the walls of a hospital, in a modern world saturated with dense news articles, shifting public health guidance, and confusing product labels, this is a fundamental critical literacy skill.
Absolutely.
You have to be able to separate a genuine causal claim from a mere list of associated facts.
When you truly understand text structure, you evolve into an active, highly critical consumer of information. You stop just passively absorbing whatever facts are thrown at you, and you start seeing the invisible architecture of how arguments and narratives are constructed.
Which brings us to a final thought I want to leave you with today. The next time you read a controversial news article, or maybe a PR statement from a massive company that just got into trouble, I want you to look closely at the underlying structure of their statement.
That is a great exercise.
Ask yourself, did the author deliberately use a loose, arbitrary collection structure to merely list things that happened in order to subtly avoid taking responsibility for a direct cause and effect relationship?
Oh, they do it all the time.
Once you start seeing the matrix of text structure everywhere, you will quickly realize how authors might be using the hidden architecture of their writing to manipulate exactly how you remember the facts.
The structure is the message, recognizing it is your best defense.
It really is. So next time you are reading something dense or difficult, don't just get distracted by the neon signs. Look for those load-bearing walls. Thanks for joining us on this deep dive, and we'll catch you next time.